Yeah. Warm it up, Chris. Wow, two. Warm it up, Chris. That's too cold, too. That's crisscross, by the way. Okay. Their claim to fame was they wore their clothes backwards. And they sang the song Jump Around. Or not Jump Around, Jump, Jump. That caddy makes you all jump, jump. Crisscross in the gym. Jump, jump. Subtract 2x from both sides gives me 3x squared minus 2x equals their whole. Factor out an x gives me x times 3x minus 2 equals their whole. Set your factors equal to their whole. X minus 2 equals their whole. X equals 0. That one works. Check, check. 3x is equal to 2x is equal to 2/3. 2/3 times 2 is 4/3. 2/3 squared is 4/9. Times 3 is 4/3. 4/3 equals 4/3. Love it! 0 and 2/3. Yes? No? Maybe. Yes? Yes? At homers? Thumbs up, side down. Good, 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 and good. Okay. Second one. So I'm looking at this and I'm saying to myself, you get two different trig functions going on in there. Let's adjust it. Let's go 3 times cosecant. Hey, cosecant is 1 over sine. At least now I've got sines all around. Minus sine of x equals negative 2. Positive equals for a second. Okay. Love it. Let's multiply the entire equation then by sine of x to get rid of that fraction. 3 times sine of x divided by sine of x is just 3. Sine of x times negative sine of x is minus sine squared of x. And negative 2 times sine of x is negative 2x. Then we got to get it equal to 0 because we still have two different trigonometric functions, even though they're the same. Technically, they're the same base function, but one's squared and one is not. We got to get it equal to 0. So I'm going everything over to the right. Because I like positive values on my squared terms. That's going to give me their whole equals, and now I'm going to write this in a algebraically sound fashion. Yesterday in class, I was noticing a lot of people were writing it kind of in a goofy fashion. I'm going to write it kind of like a trinomial quadratic, squared, linear, constant. Okay? So I squared my sine, then I got my linear sine, and then I got my constant. Love it. Okay? Now we can factor that. So that is going to be sine of x minus 3 and sine of x plus 1. Two numbers that multiply together to be negative 3 and add to be negative 2 are negative 3 and positive 1. Then we can go sine of x minus 3 equals their whole, and sine of x plus 1 equals their whole. Sine of x equals 3, sine of x equals negative 1. Can sine ever be 3? No. So that one is extraneous. Where is sine equal to negative 1? 3 pi over 2. There's just 3 pies over dose. Okay. Homers, thumbs. Good. All right, love it. So let's take a step back here for a second, and let's talk a little bit about the formative. Okay? These were just 2 examples of what we saw when we were dealing with the formative, and I grabbed one and then Phil grabbed one, but we saw this a lot of these on a lot of different things. Okay? So, for instance, in the first one, we need to, your logic has to be clear. Your thinking needs to be clear. And you need to rewrite the entire problem every single time. A lot of people we saw would just work the top or work the numerator, and then all of a sudden, miraculously at the end, the denominator would re-show up. Okay? You can't do that. You have to write it down every single time. So for instance, in this first one, yes, secant does become 1 over cosine. Yes, tangent does become sine over cosine. Yes, great first step. That's exactly what we would be looking for. But then, in this next step, where did the over cosines go? I don't know. I really don't know. Where did, so this one should have gone to 1 over cosine minus sine squared over cosine. Next. Because that would have been the simplified of what they had in their first one. Then, it should have gone to 1 minus sine squared over cosine. Because we can combine those. Okay? You can't skip steps in logic proofs. Okay? Or in logic simplification. You can't just go right to the answer. Okay? You have to show the process. Okay? Then, this would have to go to cosine squared over cosine. Then, finally, it would end as just cosine. Okay? When you lose stuff, you lose your train of thought. Or when you don't write stuff, you might lose things like this all over cosine, and then it simplifies even more. Okay? On this other one, there's a lot of stuff going on there. A lot of stuff going on there that I'm not quite sure. Yes, cotangent is cosine over sine. Yes, 1 plus tangent is secant squared. Yes, tangent is sine over cosine. But after that, how it went to just secant squared, I don't know. Okay? So, need to do some logic type stuff. Okay? So, first off, from here, I would be okay with this, except this one should have been then cosine of x over sine of x, because that's my cotangent. Secant is 1 over cosine squared. And when you divide by a fraction, you multiply by the reciprocal. Okay? So that would have been a logical next step. Okay? Then you could say that your cosines cancel each other out. If you wanted to write cosine squared of x over cosine squared of x sine squared of x, that would be beneficial. because then we could see that logic that the cosines then cancel each other out. The 1 over sine squared, which is then CSS. Which is then yeah. Logic work. Okay. Gotta show you logic. Okay. So what I'd like you to do now is I would like you all to try and simplify this, showing all of your logic. The steps that we show are the steps that we as your teachers show are the bare minimum steps, if not, we'd be, just a little bit more than the minimum. Okay? So you need to show that much per problem. Gotta have a common denominator, correct? Okay. What's missing from the first one? What's missing? Sine of x. What's missing from the second one? One plus cosine of x. Then what? What do we do next? Like, simplify it a little bit first?
Yeah.
Okay. Multiply it out to me? Yeah. So it'd be 1 plus 2 cosine of x plus cosine squared of x. They still have to keep that. Even though that top is pretty complicated and there's a lot of stuff going on there, I still have to keep it over 1 plus cosine of x and sine of x. I can't get rid of that. I can't just work the top. Okay? Alright? Then what? Cannot, because of the addition symbols on the top. If it were multiplication symbols on the top, yes, the sign on the bottom would cancel out one of the signs on the top. But because of the addition symbols, that is bad. Yes, sine squared plus cosine squared is equal to 1. Re-simplify the top again. Now what? How? How about we factor a 2 out of the top? Okay. I like that. Let's factor a 2 out of the top first. Then what can happen? Now the 1 plus cosine cancels the rest. Yep. Leaves me with 2 over sine. 2 over sine can more easily be written as 2 cosine. The reason that this is so important is because it's what we're doing in section 5.2 also. The only difference now here in section 5.2 is instead of giving you an expression to start the problem, let me see if I can put it all in one. Oh, I just can't do it. Anyway, the only difference is now we're going to give you an equation, and we're going to say prove this equation. Okay? If you have your pink homework packets, the note sheet for the rest of the day today is in there. Okay? It should start with something called like proving an algebraic identity at the top. Next one. Title is section 5.2, proving trig identities, part 1. Okay? And so what's on there is we're going to give you, so instead of what we had been doing is we had been just doing something like that. And we said simplify that. Well, when you simplify that, you should get 2. Okay? So we're doing that process for you. We're telling you that this left side simplifies to 2. Okay? Your job now is to keep working the left side and working it and working it and working it until all you have is 2. Okay? So that's your job now. We're going to give you what the simplified answer is. You now have to show us the logic that gets us there. Okay? So this logic we have worked out for you on that sheet. Okay? So again, we would have to go with, we simplified the numerator in both cases. Okay? X squared minus 1 simplifies to x minus 1, x plus 1 in both cases. Then what happens is this x minus 1 cancels out there, and this x plus 1 cancels out there. So all we're left with is x minus 1 minus the quantity x plus 1 minus the quantity x 1. Distribute our negative sign. X plus 1 minus x plus 1. X minus x is 0. 1 plus 1 is 2. So then 2 here is equal to 2. You know that you can stop once you have the other side. Okay? That's how you know when you're done. You know you're done when you reach the other side, when you've got what the other side is written. Okay? In trig form, well, first off, there is one rule to the game. Okay? And the one rule of the game is that you can only work one side. Okay? That's it. That's all you can do. You can't work both sides at the same time. You can only work one side of the equation at all. Okay? So you're going to want to pick the more ugly, scared, makes you want to like drop the pencil and walk away side. That's the side you want to go with. You want to go with the more complicated side because you can do more with it. If we go back a slide here, back to that first example, I can do more algebra with the left side than I can with just 2. 2 is just 2. That's it. Okay? I can do more on the left than I can on the right, so you're always going with the more complicated side. Okay? You cannot add, subtract, multiply, or divide to both sides. You can only work one side at a time. Okay? So, in trig form, what this looks like, we'll have verify as our answers, or as our directions, I should say. So we've got tangent plus cotangent equals secant cosecant. Yeah? Which side to you looks more complicated? Which side is more complicated? Addition or multiplication? Addition, especially in trig. Addition is more complicated than multiplication. So we're going to work the left side, or what's chosen for you to do was to work the left side. So, first step, we change, here, let me do this. First step, we change tangent to sine over cosine, and we change cotangent to cosine over sine. Okay. Then what we did, or what you could do, is you could get your common denominator. You can multiply the left one by sine over sine, and then, excuse me, we have a denominator of sine cosine. You can multiply the right one by cosine over cosine, and then we have sine cosine as our denominator. Again, just like on the formative and the things that we were doing when we were simplifying, we have to show all of our logic all the way through. So then that becomes sine squared plus cosine squared, and all of that is over sine cosine. Sine squared plus cosine squared is 1. So now we have 1 over sine cosine, right? Which is, let's see if we have it written on there. Nope. Which is 1 over sine of x times 1 over cosine of x, which 1 over sine of x is cosecant, 1 over cosine of x is secant. And there it is. Questions on that? What we're going to do now is we're going to kind of take a pause here. We were going to continue on with some more examples with this stuff today. However, going to do now is we're going to stop. We're going to give you an opportunity to fix your formative. So at Homer's, if you didn't get a 2 on your formative, actually let me tap the brakes here. Let me back that up.